Hello and welcome to the first in a series of videos on partial derivatives and higher order derivatives. Our main objective for this first video is to define the partial derivatives of a function and also to be able to calculate these so-called partial derivatives using the limit definition. Alam na natin kung paano kumuha ng derivative if our function is of the form y equals f of x. But we have been studying functions of more than one variable. So it is only natural to ask if there is still a notion of derivatives for such functions. Okay? So is there a notion of derivatives for functions of two variables? So halimbawa, if you're given f of xy equals 2x squared y minus 4y, this is just a random example. Does it still make sense to ask for its derivative? In order to answer that question, let's go back to what we know so far about derivatives of one variable function. So given y equals f of x, its derivative is denoted by dy dx. This is the Leibniz notation. Ang kagandahan nito sa Leibniz notation is that it is quite descriptive. Dy dx is approximately equal to delta y over delta x, where delta y denotes the change in the output and delta x denotes the change in the input. So kung matatandaan niya from Math 21, the delta y here is given by f of x plus delta x minus f of x. Okay? Kung gusto niyo maging equality yan, dy dx, this is equal to the limit of this expression as delta x goes to 0. So ito yung definition ng derivative na alam niyo na from Math 21. Okay? What I want to emphasize here is the following. Yung numerator, that's the change in the output. If you change the input from x to x plus delta x. Okay? So from x, pag ginawa mong bagong input ay x plus delta x, syempre yung original output mo, that's gonna be f of x. And the new output will then be now f of x plus delta x. So yung difference, so the change in the output is encoded in the numerator. Tapos yung change in the input, so if you subtract the new input and the old input, that's going to be delta x. Okay. So ang kinukuha ng derivative ay yung change in output over the change in input as the change in input goes to 0. So ito yung magiging basehan natin how we're going to be defining the notion of derivatives kapag meron na tayong more than one input. Okay. So halimbawa, we have z equals f of xy. We can, of course, ask something similar to the one variable case, like how fast will the output z change when the input x change. So gusto nating malaman yung change in output over the change in input. Pero kasi nga dito sa case natin na ito, dalawa na input natin. So we just choose one of the inputs. Halimbawa, yung x. So, yung input, pwede mong baguhin from x, gawin natin x plus delta x. So, ano mangyayari dun sa output? So, magbabago yung output, right? Yung output mo, originally, is just f of xy. Ngayon, magbabago na yung first component. Pinalitan mo na yung input x, eh. So, x plus delta x. Yung y, hindi natin babaguhin. Yung x lang yung binabago natin. Now, you can compare, again, the change in output versus the change in input. Okay. And when you do that, the corresponding expression or corresponding notion that you will get is something like a derivative. But ang tawag natin ngayon dun ay partial derivative lang. Partial derivative with respect to x. Kasi hindi kompleto yung information. Eh. We have somehow ignored the variable y. Okay. Kaya partial lang. Partial derivative with respect to x. There's of course a similar question kapag ang tinignan natin ay yung change in output as the input y changes. So yun naman ang makukuha nating notion is the partial derivative with respect to y. Okay. So yung formal definition is given by the following. So the partial derivative of f with respect to x, it's the same thing. So you look at the change in the output when you change the input. So ito yung change in input na sa denominator, plus ito yung corresponding change in the output in the numerator as delta x goes to 0. Of course, provided the limit exists. Okay. Mapapansin nyo, partial derivative with respect to x kasi yung x lang yung nagbabago dito. Okay. There's a similar definition for the partial derivative with respect to y, and it's given by this limit. Okay. So ang notation natin ay f sub x at saka f sub y. Okay. Hindi na natin pwedeng gamitin yung nakasanayan nating notion for the derivative, which is f prime. Okay. Hindi natin pwedeng sabihin f prime of xy kasi dalawa na yung input eh. So hindi natin alam kung ano yung binabago natin. What, is it x or is it y? So we have to specify by writing it as a subscript. Okay. So as an example, balikan natin yung tanong sa simula. No? How do we find the derivatives? So in this case, how do we find the partial derivatives of this function f of xy equals 2x squared y minus 4y. Yeah. So this is the definition of the partial derivative with respect to x, right? So ano lang, evaluate lang natin tong limit na to. So to get f of x plus delta x comma y, papalitan lang natin lahat ng x dito sa expression natin ng f of xy by x plus delta x. So ito yung lalabas na. 2 times x plus delta x squared times y minus 4y. And then f of xy, ganyan pa rin yung tsura niya. So pag in-expand mo yung numerator, first notice yung 4y and negative 4y magka-cancel. Okay. And then pag in-expand mo yung binomial dito, yung square, magiging x squared plus 2x delta x plus delta x squared. And then you have to multiply that by 2y. So ito na yung lalabas, tong tatlong term na to. And then magka-cancel yung 2x squared y. So ang matitira lang yung 4xy delta x plus 2y delta x squared all over delta x. At syempre, pwede ka pang mag-cancel ng mga delta x na. So pag ginawa mo yun, pag kinancel mo yung mga delta x, ang matitira ay 4xy plus 2y delta x. Okay? And then we have to take the limit as delta x goes to 0. So pag ginawa mo yun, itong part na to mag-0 na. Okay? So ang matitira na lang ay 4xy. That's the limit. So ito yung partial derivative natin with respect to x. This is equal to 4xy. So similarly, for the partial derivative with respect to y, ito naman gagamitin natin definition. So titignan lang natin yung change in the output kapag binago mo yung input y. Okay? So yung magbabago sa output, syempre yung y magiging y plus delta y. So again, papalitan lang natin lahat ng y plus delta y. So ito yung lalabas. Pag ginawa niyo yan, this is still minus f of xy. So expanding, pag in-expand natin to, what we get is this expression. So 2x squared y plus 2x squared delta y minus 4y minus 4 delta y. Tapos ito, distribute ko yung minus sign. So that's going to be minus 2x squared y plus 4y. Right? And kung mapapansin nyo, you can cancel out 2x squared y here and negative 4y with this plus 4y. So ano nang matitira? So ang matitira na lang ay yung 2x squared delta y, okay, minus 4 delta y. And then of course, pwede mo i-cancel yung mga delta y's dyan. And if you do that, ang makukuha mo is just 2x squared minus 4. Magiging constant na lang siya with respect to delta y. So the limit is itself. So this one is the partial derivative of f with respect to y. Okay. So, just to summarize, in this first video, in a series of videos on partial derivatives, we defined what the partial derivative is of a function. So it's defined as a limit, okay? And we were able to calculate the partial derivatives of a particular example using this limit definition.